Hi, hi to all. Today, as I told, we are going to see on off logic, but in this case, the off push button will be wired in NC element. The difference between that NO and NC we can see here. So this is consider this block is a PLC. The left side we will connect inputs. The right side we will have outputs. It is a compact type PLCs. Okay, compact type PLC means PLC which have both inputs, outputs and CPU in single block. It is compact type PLC. The modular type means it will have CPU separately, a base rack will be there, power supply will be there, inputs will be there, outputs will be there. That we can see in details. Okay, let me give you one example for the PLC, compact PLC, this Mitsubishi, how it will be. Let me show you some images. These are all the compact type PLCs. Why it is compact means the PLC will have a processor. The top terminals are used as inputs, bottom terminals are used as outputs, and this is the programming port. Okay, so it is a compact type PLCs. So we can use this type of PLC for some simple applications. This is modular type. It will have a base rack, a power supply and a CPU unit, and based on our requirement we can add inputs, outputs. If we have analog requirement or servo requirement, we can add some intelligent module in that also. So it is modular type. For big applications they will prefer for modular type PLCs. It will work much faster. Okay, so in this video we are going to see how we need to do programming for switch on output with two input. This input is this one, x0 and x1. Before that, this example or this video is related to Mitsubishi FX3U PLCs. So this Mitsubishi FX3U PLC will have addressing in the format of octal addressing, that is from 0 to 7. Octal means 8. So from x0 to x7 it is 8. After that it will continue with x10, x17, then x20, 27. Means 20, 21, 22, 23, 24, 25, 26 and 27. This is the addressing method for Mitsubishi FX PLCs. Like this. We consider inputs. It will start from x0, x1, x2, x3, x4, x5, x6, x7. Then it will start from x10, 11, 12, 13, 14, 15, 16, 17. Again it will X20 and it will continue. For the outputs, Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7, Y10, Y11, Y12, Y13, Y14, Y15. So it is a total addressing method. So it will start from 0 to 7 and then 10 to 17 and 20 to 27. This is how this addressing will be. For memory bits, it will be M0, M1, M2, M3. It will be continuous. It will be continuous based on the PLC capacity. The memory bits range will be in the thousands. It will be in the range of thousands. And data registers. Data registers are used to store values. It will be starting from D0, D1, D2, D3, D4, D5 like that. Okay, so these are all general elements or addresses that we will use in programming. Okay, inputs, outputs, memory bits and data access. This input outputs are the physical element that we will connect through external. Okay, this inputs and outputs, and these memory bits and data registers are used, or it is stored inside the memory. That ranges will be depend upon the PLC memory. Some basic PLC will have in the range of 0. For example, if we take data registers, some basic PLCs will have in the range of 0 to 7999, that means 8000. Some higher end are having 32,000 registers or 64 registers, and some PLCs we can extend the memory through cassettes also. Okay, this is just for an input I am saying. Okay, so here let me get into the topic. Here as I told, we are going to connect one input through NO element, this X0. The second input is X1, it is through NC element. How it will work? The NO element is it will be in open. NO means normally open, so the button will be in normal open state. If we press this push button, the supply from one side of the button, that is the element, will get closed. So the supply from one side will pass into the other side, and through that wire it will get into the X0 input. It is NO push button. In other case, that is if we use NC push button, by default the circuit will be in closed state. So from the supply through that NC, normally closed element, the supply will get passed into the terminal. So the X1 will get the input by default. If we press this input, this push button X1, what will happen is the NC will become open. Just think of it, if we press, if it goes down further, the contact between these two lines is released. Okay, so the supply will be cut off, so the input at the X1 will turn off. So if we press the button, PLC will not get the input. you need to consider like that. Okay, and for the output, the supply what we are giving at the common terminal will be coming out from Y0 or the outputs. Okay, whatever outputs we are using, it will be coming out. So here in this case we are giving plus 24 volt to the common of the output common of the PLC. So we are getting at Y0 is plus, and this box is a load symbol, and the other end of the load we are connecting to the 0 volt of DC. Okay, so the lamp or motor or solenoid, it will energized if the output Y0 turns on. So this is the electrical circuit what we are going to see in our example. Okay, let me open the file. The software what we are going to see is JXWorks2. The previous video itself I have told you about some little bit about that software. So here I am going to select FX PLC. So there are many type of PLCs are there in Mitsubishi. We are going to see FX PLC, and the series what we are going to see is FX3U. It's simple project. There is two type of projects, simple and structured project. For some big applications, for some special codings, we will go for the structured project. Now we are going to use simple project, and the language what we are going to program the application is through ladder logic. So we are going to select the language in ladder. Okay, so we are already having the input and output. So let me type it here. It is on push button, and the another push button is off push button, and the output considered as a motor. Okay, so this is the device command area where we can enter command for each address or each devices or each memory bits. Okay, now we are going to open the program file. POU is a programming unit. So here already I told about the ladder. Once again I am saying the left side is the line and the right side vertical one is the neutral. Intermediate we will create the condition to connect between the line and the neutral. So once it is get connected with the circuit or something will get closed, our circuit or our condition is get executed. Okay, then our respective output or something will turn on or off. So now our requirement is, if I press the push button, the motor should run continuously even if I release the button, and if while running, if I pressing this input X1, the motor should turns off. This is the requirement. So first input what we need to take is X0. We need to select the NO element, NO contact, and need to select enter the address X0. If we need to see the command, we can select like this. Once the X0 is on, we need to switch on the motor. So if we So if we write the rung like this means, what will happen? If we press the button, the motor will run. If we release the button, the motor will off. You want to see it? Let me show it in simulation. So if I switch on or if I press the button, the motor will run. If I release the button, see the supply goes off, so motor will turn off. So if we release the button, then motor should on. Even if you release the button means we need to put holding coil. So that holding we can put like this. Where we need to add the holding? Here. On what is the holding address register? Or holding register address, what we need to put is that Y0. So if Y0 is turned on, it will be holding through this holding register. So now if we run it, it's X0. If I press, Y0 will turn on. If I release, also the Y0 will remain in on condition. Okay. So it is the purpose of the holding registers. Okay. Now we need to turn the motor to off if we press the X1. Before putting it, you need to think that X1 is wired in NC element. So we will get the input always by default. If we press that X1, that push button, the input to the PLC will goes to off. So if I put it as previous one like this means, you think that input to the X1 is always in on. So the NC element, how it will work means, if we use an NC element in program, if we get that input on to the PLC, the NC element will become open. So the NC normally closed will become open. So here if it get open, then the output Y0 will not turn on. Okay, you can see clearly here. So this is the X1. In the drawing we have seen that X1 is using NC, so always we will get the input in X1. So if we turn on the X1, see the circuit is get breaked here. Even if we put that X0 turns on, the output Y0 will not run. The motor Y0 will not run because the X1 is in on state. But we didn't press the button, okay? But we have connected X1 in NC element in electrical. So that we are by default we are getting the input X1 always like this. See the X1 become 1 and X0 it is in 0 state. So what we need to put is we need to use another element instead of NC to make our motor run. So what we can do, so what it is actually happening, by default we are getting input to x1. If input is on, the NC element will become open, but the NO element will be closed. So we can use NO. And now we can check by default we are getting the input, so it will be like this. If we switch on the motor and switch off the X0, that on push button, the motor will keep on running. So once we press the X1, see the X1, it is in on state already. Okay, so if we press, what happen, the PLC, the input will goes off. So if it goes off, what actually happening is the holding, we are getting supply from holding, but here the circuit is break, so the Y0 will turn off. So once this rung, the continuation is break through that X1, the output Y0 will turn off. So based on the element NO element or NC element in the field plus in our program, the function will vary. Okay, so based on the field wiring, we need to develop program. Okay, so next video I will have some useful topics or beginners topics from about PLC, how it is working, what are all we will connect to the PLC, what are all having in the PLC, like that. Some theory part or similar to that we can have. Okay, please subscribe and like the video and follow the channel to have more videos. Thank you. Have a nice day.